Hello friends, this is lesson 21st part 1. So here we are going to talk about the second type of machine learning, which is called unsupervised machine learning. So the first part, which was supervised, we discussed in previous lectures. So today we are going to talk about unsupervised machine learning. So we have to understand what is unsupervised machine learning, then we will talk about the type of supervised machine learning, which is called clustering, and then we'll talk about the metrics of unsupervised and we'll give some examples for them. So let's start with the first topic. So the first topic is the question, what is unsupervised machine learning? So we have to know, the name itself also indicates that unsupervised. So the name itself suggests that the machine itself clusters the data or objects based on some common patterns between them. So it means here the user or the programmer, we can say, or the person is not guiding or supervising the machine, but the machine itself takes the decision and clusters the data based on some similarities or common patterns between them. So here we work with completely unlabeled data. From here also you can understand that we need unlabeled data. So if it is labeled data, it means that is supervised machine learning, but in unsupervised machine learning, so here we need only unlabeled data. If label is also there, so it will be ignored. So we have unlabeled data, and the machine itself clusters the data based on some common patterns, similarities like that. So the user is not supervising the machine, so the machine itself is taking the decision and predicting the pattern or the output or the outcome. So when to use unsupervised learning? This is the question. So here there are three cases, maybe more than this. Okay, the first case is there is no clear response variable. If you don't have a clear outcome or response value, so it is better to use unsupervised machine learning because we don't know about the outcome of the data or the response variable or response value of the data or predicted values. So for that we are using unsupervised learning technique. Again, here another example or where we are using unsupervised machine learning, it is for feature extraction. So feature extraction, you know that we are creating some new features or super columns from the existing ones. If you remember this, we discussed in previous lectures also. Here also the process of creating new features from existing ones. So from existing ones, if you want to create some new features which are stronger than the previous or the original features, so in that case we will be using unsupervised learning for creating new features. So that will be, the decision will be taken by the model itself. It calculates the relationship between or correlationship between the features, then based on that the higher or the stronger features will be selected. So next one is to extract structure from data where no patterns exist. So again, if there is no relationship between the features and we don't know the relationship between the features, how the features are related to each other, so it is better to fit that data to the model, unsupervised model. So the model itself will find the structure or the pattern, or we can say the relationship between the features if we don't know. So some of the applications where they are using unsupervised method, so in recommendation systems, for example Amazon.com or other online shopping system, they are using unsupervised because we don't have label data. The labels or the features will be decided by the system itself or the model itself. So searching engine, it is unsupervised learning method like Google, example is given. So now here Let's see the type of unsupervised machine learning. The first type is called the clustering. So let's see what is this clustering here. So clustering is the process of grouping the features, or we can say the predictors, based on their similarities. The model itself predicts and finds the relationship between the features or predictors, and that relationship may be based on their similarities and based on the correlation, or we can say the relationship between the features. Some examples are given, like if your the features are like color, size and some shape, so based on these features will be the predictors will be classified or grouped, and they are called clustering. For example, all red items will be clustered under first cluster, and based on size, maybe the size is larger, then we have large, then we have small. Based on that, like that, they will be grouped, and that group is called the cluster. And the algorithm which is used for this purpose here, it is called k-means. So now let's talk about the metrics that we can calculate under unsupervised machine learning. The first metric is homogeneity. So what is this homogeneity? If all of its clusters contain only data points which are members of the same original or single class. The name itself suggests homogeneity means the data under a cluster, if all the data points under a cluster are the same, means it does not have mixture. So that is called the homogeneity. So homogeneity means here the purity of data. So that cluster has pure data, it means it does not have mixture in it. So if that is the case, it will return the highest percentage, and that is desirable or preferable. The second one is called the completeness. So what is this completeness? If all the data points that are members of a given class are elements of the same predicted class. It means the predicted values and the cluster values, we can say, or the class values, if both are the same. For example, the class values are 1, 2, 3, and what we predicted and clustered, that is also 1, 2, 3. So it means it is completeness is applied there, and it will return the highest percentage which is preferable or desirable. So both here, homogeneity and completeness, have real positive values, and that will be between 0 and 1, and the larger one is desirable. So the next one here we have V measure. So what is this V measure? V measure is nothing but the average of completeness and homogeneity. If we take the mean, means the average between the homogeneity and the completeness, that is defined as V measure. How to calculate that? V is equal to 2 times homogeneity into completeness divided by their total. So this will return the V measure. Another matrix is also there. This is called sellout score. So what is a sellout score? Sellout score or coefficient is calculated for each observation as follows. This is the formula for this. This is sellout I is equal to B minus A divided by their maximum. So now the question is, what is A and what is B then? So A is nothing but the average distance to all other data points in the same cluster. So in the same cluster, if you want to find the average distance between the data points, and that is nothing but A. If you want to find the mean or average distance from this cluster to the other data points nearest, or we can say the next nearest clusters, so that will be nothing but B. So we subtract that and divide it by their maximum, and that is called the sellout score, or it is called sellout coefficient. So we will give some examples for them, and then you will better understand, friends. Now let's see here what do we have. Okay, unsupervised learning, we said it is a type of machine learning where we don't have labeled data, or if we have labeled data, that will be ignored because the machine or the model itself creates the features, and the process is also called feature extraction. So grouping the features based on similarity, if that is happening, this is the first type of machine learning, which is called clustering. So clustering is the process of grouping features based on similarity, where each group is called cluster. Now we say that algorithm which is used here, it is called k-means algorithm. So how that this algorithm is used to cluster the values, it attempts to group data points into cluster with sunlight. So it first find the sunlight. So after the sunlight, based on that, it will group the different features nearest to the sunlight. Now let's see here, friends. From here, from this figure, you can easily understand. So here, all the data points what do we have? They are in the form of mixture. They are mixed. So how to purify this? So the machine itself will do that. So see, all the blue points are clustered here, and all this orange points are clustered here, and all those red data points are clustered here. Now they are separated into different clusters. So this is group 1, group 2, group 3, and to 3 groups. Here it was in the form of mixture, or they were mixed together, and now they are separated. And for each group, you see that we have a yellow plus sign. So this yellow plus sign is nothing but the sunlight, or we can say the center of the cluster. For this cluster we have this center, and for this cluster we have this center, and for this cluster we have this center. How these centers are selected for them? So here we have the steps for that. Initialize the cluster center. First we initialize a cluster any value. So based on that, it will compute the minimum distance and assign spines to the new cluster, and this will be repeated until the center will find its position, and then it will be fixed and no further will be moving this side or that side. So it will find, because here it is in the middle, all the points are around that. If you are moving this here, so it means the points, some points are having the average distance between the points or varying. So that is not the case. So it should be in the right position like this, or like this we have to say. Let's have an example for this, friends. Then you will better understand how to cluster the data. Now we are using pandas library. Here I am reading the data set which is called the drinks. If you remember this drinks data set, so it has some columns and response values or unknown, and we don't know about the response value or response variable. Let me execute and you will see the features here. Yeah, we have country, and then we have feature 1, feature 2, feature 3, and feature 4, and then again we have the continent here. We cannot say what is the outcome for this data set, or we cannot say what is the response value for this. So if this is the case, what we are going to do, we are going to first, I will drop these two columns, because country and this one, they are qualitative values, and we see that machine or model needs only quantitative values. So these values should be converted, they should be converted to like numbers, or otherwise we have to drop them or remove them from the data set. Here these two I have removed. If the two columns are removed, then we will be having only these 4 features here, and they are quantitative values. So how many rows we have? 139 rows and 4 columns we have. Now let us cluster this. Let me group these values. How they will be grouped? So based on their sizes. For example, all larger numbers will be grouped in first cluster, smaller values will be grouped into the second cluster, maybe the middle numbers will be grouped into some other cluster, 3, 4 class, how many classes we want. So based on that, not how many friends. Here one thing you have to remember, we have only 4 features, then the number of classes should not be more than 4, but we can have 1 cluster, 2 cluster, 3 classes, 4 classes also, but not more than that. Okay, for that, if you remember, we talked about k-means. We are using this algorithm or this model, which is nothing but it is algorithm for clustering in unsupervised machine learning. So I am using here scikit-learn dot cluster, and from that I am importing what? K-means. And now I specify and create an object for this, and I specified here the number of clusters. I say how many clusters I want. I want only 3 clusters. So 3 clusters will be created, and after that, if you remember, in machine learning we will be fitting the data to that. So what is the data? X. The x is nothing but these values here, these values, 4 columns. So this data set we can say, or data frame, and that is fit to the model. What is the model object? K-means with small k here, because this is different from this. That is the model itself. In here I am creating the object for that. And then we are going to find the centroid. So centroid, if you want to calculate or you want to find that, model dot cluster underscore center underscore cluster, we are using this attribute, and through this the object returns the centroid for us. And now what we are going to do, we are going to cluster. We say based on labels, how many labels, save the cluster labels and sort by. So we say k-means, then labels, you return that and give the title cluster and store it in the same data set drink. So here I say, okay, you group clusters and find the average for them, and then you store that under the center, and then I specify the colors for them, and then again I want to group the cluster and find the average. Let me run this and you will see here. Okay, it's taking some time. Yeah, now see how many clusters are created. 3 clusters according to this value what we have given here, 3. So 3 clusters. Cluster 1 is 0, cluster 2 it is 1, and it is 3 clusters. And now here friends, you can easily identify, or you can easily understand how they are clusters. So these values, you compare these values. So the first value is the average for cluster 1, or these values, but these values are smaller than that. So smaller values are clustered under this group 1, and larger values are clustered under cluster 0, and further larger, like largest values, and they are clustered under, see, based on their values or similarity, smaller values, then we have small values, and then we have large values, and they are clustered or grouped like that, and 3 clusters are created. You can create any number of clusters. It is not like not any number, not more than 4, because we have only 4 features. You can create like 2. Okay, now 2 clusters we have, see, 0 and 1, and you know that the difference between these are small values and these are large values, and you can change it to like 4. Again you can see here, yeah, smaller, these are the smaller, then based on that the values are clustered or grouped. Let it be 3 only here. We have 3 groups or 3 clusters are created, and these are the values. I hope you understood these things. Now let me visualize or plot them here, then you will better understand the output. So we said how many clusters we want? 3 clusters. So cluster 1 with red color, another cluster with green color, and we have cluster with blue colors. So these plus signs are nothing but the centers for this cluster, and center for this cluster, and center for this cluster, and it is automatically calculated here, friends. Yeah, this is the center, it is calculated. And now here which features I have considered. Only two features, beer servings, and I say spread servings you take as a x and y values, because I want to scatter plot, PLT dot scatter plot, and we provided in color. We are choosing from the list what we created here. These are the colors. We say you take the colors from this list, and size of the points, and size of the points are equal to 50. But for these plus signs, the size is increased to 300 because these plus signs are large, and then the color for that is black. And we said centers dot beer servings. You find the center for beer servings. This is the center, and beer servings you take from that. In the same way, length of weight we have specified 3 here. The plus sign has some weight. And then I have specified beer servings and spread servings, and these are here x and y axis. So here you can easily understand that they are classified into 3, and we have here blue, red and green, and these are the centers, and automatically it is classified, and it is nothing but the mean for this cluster. This plus sign is the mean for this cluster, and this one is the mean or average for this cluster, and all data points are calculated, and center is localized here. It is fixed, it is not changing. If it is changing, it means the data points are it is changing for some times after it finds its proper location. And now let's talk about the matrix. And first we talked about the homogeneity. We said homogeneity means if all the classes contains only data points which are members of the same classes. Let me show you here, friends. What do you think about this cluster red? It is not pure, it is not homogeneous, because it has some values from blue also in it. You see, the blue values are also mixed with red one. And what about blue? The blue points also have mixture of the green, and the green also has some data points from red and some data points from blue. So it is not like all the classes are not homogeneous. And completeness, like what are the actual values and what are the predicted. If actual values are the same as predicted, so it means the completeness is applied there. And then we talked about the V measure, and said V measure is the average of those two, completeness and homogeneity, and this is a formula for that. And then we talked about the sellout, and we say sellout is nothing but the distance, the average of the distance between the same cluster and with other cluster, the data points. So now let me show you here some examples, friend, then you can easily understand. This is the homogeneity. We are using matrix homogeneity score. So if this is the first cluster and this is the second cluster, what do you think? Is it homogeneous? No, because in first cluster we have 1, so this is, it will create a cluster for 1, and these 3 zeros will be moved from this cluster to this cluster. So the second cluster, it has 4 zeros from the same cluster, and 3 zeros will come from this cluster, so it means it has some mixture. What is the value for that? It returns 0. So the homogeneity is 0 because it has the mixture. And now let's see the completeness. The completeness, if this is the first data set or cluster and this is the second data set cluster, and after that what will be the predicted value? So again we will be having two clusters, one cluster of ones and one cluster of zeros. So again we will be having 4 zeros in one cluster and 4 ones in another cluster. So what is that? Yeah, 100%. And now if you want to find the V measure, in V measure we said this is a formula, it is the average. So if homogeneity is 0, so 0 into completeness, so it becomes 0, 0 divided by other numbers, so that it will return the 0. This was a simple example. Let us apply it to our data set here, and you will better understand what are the values here. So homogeneity is not 100% because I told you it has some mixture. The values are mixed somehow, they are mixed, they are not pure. So the red cluster has some data points from green and also from blue. The green also has some data find some minor data points from all the groups or clusters. So here it is showing us like that. So this is the homogeneity. Yeah, the completeness is also not 100% because you know that the predicted values and the actual values are not the same, and V measure is also not 100% because this is not 100% and this is not 100%. If both were 100%, so the average also would be 100%, but it is not here. The cell out here, it is coefficient is equal to how much? 50% or 52%, we can say the average distance between the same cluster and from the same cluster to the other data points, the average it will be calculated. So it is called the cell out coefficient or score. So this is all about cluster inference. I hope you understand, and this example if you understood, then you can easily have the logic that it means. So we talked about the data set, how to fit it to the model and how to create the model and how to visualize in groups. Here these are the clusters and here we visualize the data, and you can easily understand how they are grouped or clustered. And then we talked about some metrics here like homogeneity, completeness, V measure and cell out. I hope you understood this much about the first type of unsupervised machine learning, which is called clustering.